Hello viewers, welcome back to another section of my YouTube channel tutorial. In this video, I'm going to take you through the type 1 of mathematical induction, and that is sums. So under this, I have a problem. Prove that 1 squared plus 2 squared plus 3 squared plus n squared is equal to n multiplying n plus 1 multiplying 2n plus 1 all on 6. So this is the mathematical statement we have, which we are going to use mathematical induction to prove that is true for all natural numbers. So, from our previous video, I showed you that the first step is what we call the base step. The first step is what we call the base step or base case. So for the base case, we are going to show that our statement P of n is true for n equals to 1. That is the least value of n. In our statement, you can see that the least value of n is equal to 1. So on the left side, this thing here means that the sum of the first n term, that is 1, and that is equal to 1 squared, is equal to, on the right side, wherever you see n, you put 1 there. So 1 plus 1, multiplying 2, open bracket, 1 plus 1, everything on 6. So 1 squared is 1. 1 plus 1 is 2. Multiplying this is 2. 2 times 1 is 2 plus 1 3. All on 6. So 1 is equal to 6 on 6. Then 1 is equal to 1. Hence the base case has been proved. That is true. The next step we move to the inductive hypothesis. At the inductive hypothesis, you assume that the statement P of n is true for n equals k. That is assumption. So we are going to assume that for n equals k, this statement is true. So our new statement becomes P of k is equal to 1 squared plus 2 squared plus 3 squared plus dot 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 plus k squared is equal to k open bracket k plus 1 2k plus 1 all on 6. So at this point, we are going to say that this is our assumed statement, and this assumed statement, our left hand side here is 1 squared plus 2 squared plus 3 squared up to k squared equals this, and it's true. So P of k is true for all, that is, the statement is true for n equals k. That is an assumption. From here we move to the third step, which is inductive step. So for the inductive step, this is what we are going to do. We are going to prove. So we are going to prove for n equals k plus 1. So we have to prove that the statement is true for n equals k plus 1. That is the inductive step, and that is basically the goal for our mathematical induction process. Once you have assumed that the statement is true for k, then it should be true for k plus 1 term. So that if the statement is true for 5, it should be true for 6. You get it? If it is true for 7, it should be true for the k plus 1, the 8th term. If it is true for 10, it should be true for 11. So our new statement here, which is p of k plus 1 here, becomes 1 squared plus 2 squared plus 3 squared plus k squared itself, then plus k plus 1. So at this point, you can see that the k squared is here, then plus its other term, which is what? K plus 1. And all this should be equal to what we have on our right hand side. That is k plus 1 in one bracket, then k plus 1 plus 1. Then we're going to have 2 multiplying k plus 1 then plus 1. Everything on what? 6. So let's see something here. So once we have this, you realize that wherever we see and we put k there. So here, wherever we see and we put k plus 1, that is why we have k plus 1, k plus 1, we had k plus 1 plus 1, 2 open bracket k plus 1, then plus 1. That is the reason for what we have done. So at this point, I'm going to simplify. We are going to show that the left hand side is equal to the right hand side. From our inductive hypothesis, we show that 1 squared plus 2 squared plus 3 squared up to k squared is equal to this here. And we are going to use the hypothesis to prove for our inductive step. Meaning that if I take the 1 squared plus 2 squared plus 3 squared up to this k squared, I can replace everything here with our what hypothesis, right? So my left hand side is now going to be k plus, my left hand side is now going to be k open bracket k plus 1, then 2k plus 1 all on 6 plus this is it. So all these places has been replaced by k plus 1, 2k plus 1 plus k plus 1, this place all squared, sorry. Then this being our left hand side should be equal to our right hand side, which is this side, which is k plus 1, k plus what 2, then open bracket here is what 2k plus 1, so it's going to be 2k plus 2 plus 1, so 2k plus 3 all on 6. So left hand side is this, our right hand side is this. So all these things here should be equal to the right hand side. How do we show that? Let's take the left hand side alone and we express it to look like the right hand side. So see, if you have this here, I can factorize k plus 1 is here, k plus 1 is here. I can factorize this out. So before I factorize, let me make this one a single unit. So I'll get k plus 1, 2k plus 1 plus 6 multiplying k plus 1 all squared, all on 6. This is my left hand side. So let me go on simplifying. Here I can factorize k plus 1 out. So k plus 1, k multiplying 2k plus 1 here plus what? 6k plus 1. Everything here on 6. So k plus 1 here is going to be what? 2k squared plus k plus 6k plus 6 all on 6. And simplifying this, I'm going to get k plus 1 multiplying 2k squared plus 7k plus 6 all on 6. Now let's see if you, so this is our left hand side, now let's see our right hand side. So our right hand side is equal to, so this is the right hand side, k plus 1, k plus 2, then 2k plus 3, right? All on 6. So you have k plus 1 out, k plus 2, then 2k plus 3 all on 6 on our right hand side. So we can multiply this out here. So k plus 1, we want it to look like this, so k plus 1 will stand out. So I'll get 2k squared plus 4k plus 3k then plus 6, all this on 6. Then I'll move further to get k plus 1, 2k squared plus 7k plus 6 all on 6. So now this is our right hand side, this is the left hand side, k plus 1, 2k squared plus 7k plus 6 all on 6. The right hand side to k plus 1, 2k squared plus 7k plus 6. Since LHS is equal to RHS, the left hand side is equal to right hand side. Therefore, the statement D of n, where we had 1 squared plus 2 squared plus 3 squared plus up to n squared, is equal to n open bracket n plus 1 2n plus 1 all to the power all over 6 is true for all natural numbers n. And this is how we prove using mathematical induction. Thank you for joining me in this video. Please join me in the subsequent videos where we're doing the divisibility as well as the inequality. Thank you.